Hey everyone, today we're going to talk about some properties of logarithms. The first thing you should remember when you're working with logs is that the output of a logarithm is an exponent. A logarithm is a tool that recovers an exponent from exponentiation. What do I mean by that? Well, let's say we just finished exponentiating something. We took our base, we raised it to an exponent, and you get some result. So, equals result. The logarithm of that base of your result is just that exponent. In some sense, it undoes the process of exponentiation. You can view this whole expression as just one big block that stands in place of one number, the exponent. Now, because logarithms are exponents, every log property is really just an exponent property in disguise. For example, we have the property that if we add two exponents and raise a base to that sum, this is the same thing as multiplying the two different results that we would get from raising the base twice. Symbolically, we have b to the power of e1 plus e2 is equal to b to the power of e1 times b to the power of e2. Let's name our results of exponentiation. So we'll say that b1 to the power of e1 is equal to result 1, r1. We'll say that b to the power of e2 is equal to r2. And this lets us say, without using a third variable, that b to the e1 plus e2 is equal to r1 times r2. We can now use logarithms to recover our exponent, giving us log base b of r1 is equal to exponent 1. Log base b of r2 is equal to exponent 2. And log base b of our third result, which is actually r1 times r2, is equal to our third exponent, which is actually e1 plus e2. Once again, you can think of each log expression as just one big block that is equal to some number, right? The number that we're exponentiating by. What we've essentially done here is just renamed our three exponents. However, this renaming lets us write log base b of r1 plus log base b of r2 is equal to log base b of r1 times r2, because log base b of 1 is e1, log base b of r2 is e2, and log base b of r1 times r2 is e1 plus e2. This here is our first important log property that we just got from an exponent property. Let's do that again, this time converting a different exponent property. This time the property we're going to use is that multiplying the exponent by a constant is the same as exponentiating again. As an exponent property, this means if we've got some base b, raise it to the power of a first exponent times some constant c. This is the same as raising b to the first exponent, then raising that entire thing to the second exponent, or the constant we just had. Once again, naming our results of exponentiation, we get b to the e1, we'll call that result 1, And once we've written that down, we can say that b to the e1 times c is equal to result 1 to the power of c. Because result 1 is equal to b to the e1. Recovering our exponents with logarithms again, we get log base b of r1 is equal to e1, and log base b of r1 to the power of c is equal to e1 times c. Finally, if we take this equation and substitute in our first equation, we get log base b of r1 to the power of c, so left side unchanged, is equal to our other name for e1, log b of r1 times c. And this is our second important log property that we've just derived from an exponent property. Now, we can actually get even more mileage out of the last property. Let's write down that previous property again. B to the power of one exponent times another exponent is equal to b to the power of the first exponent, all raised to the power of the second exponent. Once again, we're going to name our results, but this time we're going to name them a little bit differently. We'll have b to the power of e1 is equal to result 1 as before. And we're going to say that r1 to the power of e2, notice that I've used red for r1 here to indicate that it's now a base, or that we're now treating it as a base. We'll call the result of this exponentiation r2. And note that this is equal to the result of our left-hand exponentiation, or b to the e1 times e2. Now this lets us write down three different logarithm expressions. For the first equality, we have log base b of r1 is equal to e1. For the second one, we have log base r1 this time, because r1 is our new base. Log base r1 of r2 is equal to e2. And for our third equality, we have log base b of our same results, r2, is equal to e1 times e2. So recovering the exponent in each part, like before, just by taking the logarithm. Now this gives us that log base b of r1 times log base r1 of r2 is equal to log base b of r2, because this first expression here is e1, this one is e2, and this one is e1 times e2. This property is often called the change of base formula, and it's a lot of the times written like this, just in an equivalent form that we get by dividing out that equation just above it. So log base r1 of r2 is equal to log base b of r2 all over log base b of r1. In both cases, you can kind of remember the property just by imagining that you're canceling out bases. Now this isn't what's actually happening, because these aren't really fractions that we can cancel out, but that's just a way that a lot of people decide to remember this property. In any case, this change of base property is the final log property that we'll be talking about today. So to summarize, today we derived 3 different properties from exponent properties. We first have that log base b of one result plus log of the same base b of a second result is equal to log base b of the 2 results multiplied. Secondly, we have that multiplying a log expression by a constant means that we raise the results to the power of that constant. So c times log base b of r1 is equal to log of the same base r1 to the power of c. And finally, we have the change of base property, usually written as log base r1 of r2 is equal to log base b of r2 all over log base b of r1. That'll be all for today. Hope you guys found this video helpful, and see you all next time.